Ladies and gentlemen.
Welcome to the Reliability U podcast with Brett Scott and Adam Lunt, where we talk about all things reliability. Stay tuned. Hey, everybody, welcome back to the Reliability U podcast. Today, we're going to talk about some different topics, kind of pick up where we left off on a few things we talked about in the last episode. As always, I'm one of your hosts, Adam Lunt. With me,
Brett Scott, how you doing?
hey, Brett, how's things going over there, buddy?
Good. Yep, decent. Back home, so it's a rare opportunity where I'm back home, not on the road somewhere. So yeah,
So, did Tracy pick out that wallpaper for you?
yeah,
Is that the wallpaper in your house now?
it's everywhere. Yeah, yeah, yeah. She gets
It
tired of
looked
it, but everybody else seems to like it.
At least it's easy to wipe off if the kids smear stuff on it, right? Being
Right.
laminated.
Yeah.
Yeah, I didn't get to do the official wallpaper like you. Mine's digital, but yeah, I think it drives the point home on what we're trying to do here.
Right. Exactly.
Yeah, so let's pick up where we left off. We talked quite a bit over the last couple episodes. It's got brought up a few times, talking about continuous monitoring vibration versus going out and running a route. I know you and I have both done both and probably seen that one definitely has benefits over the other. I don't think either one is a complete, replacement. I think it's a good complement for each other, like we've discussed in the past.
Yeah.
Kind of tell me your thoughts and where you've seen this in industry. I mean, obviously, route-based has been around a lot longer.
Yeah.
Um, but where do you see this going in the future?
Yeah, I've had, of course, both. Started years ago only doing route based. That was pretty much the only option, other than some wired devices that were out in the field on some of your more critical machines. Those have been around for quite a while. But normally, people weren't really monitoring and doing what you'd call routes with any kind of remote data. It was always carry a data collector around with you and collect the data, go back, upload, analyze, etc. So I spent most of my career doing that. But, within the last probably 10 years, I've seen quite a few more places trying to go with the either wired or wireless. There's both options out there to eliminate some of the time spent having people going out, employing somebody else to go collect data that, if you lose that person, that is the one advantage. And I guess that's a good point to bring up right now. Advantages and disadvantages. Advantage of the online versus having a person go out and do it is the person going out and doing it, if they leave, the new guy that comes in, or if they even have two people on staff or three or whatever that are collecting routes, and they swap each other's routes, and one guy's collecting 1 month, the next guy another guy is. That's one of the risks you take is. Are we taking it in the exact same spot? Does this person know where I'm taking the readings? Because we even have data that shows surprisingly a few inches, honestly, can make a difference on where you put the transducer on the machine. Interfaces on like motor end bills and things like that. Just a couple inches can actually change the data by quite a bit. So right, wrong, or indifferent, where you've taken that. If you're not taking the same spot every time, you have that issue. So online wins that category. If the thing stays in place and is mounted, either stud mount or adhesive mount or whatever it may be, this thing staying in the same spot. It's very repeatable data. It's going to be in the same place every time. So that makes that definitely a win category for the online stuff. But also, with taking that human out of there, there's a little bit of that human element, the gut feeling, the I know what this machine sounds like, something smells funny. Right now, there's no smell sensors that they're installing on these. But honestly, that is one of the senses occasionally that you'll pick up and be like, something don't smell right, something feels strange. And again, we mentioned last time, we're not going to taste it. Fine. I learned my lesson there. We won't be doing that. But the
I'm
other
going to stay on you on that one.
the other senses, though, they do provide some stuff that, even though
Yeah.
AI will get there for sure, it's not yet, or at least not even AI, but even the online stuff, it's not there yet. We're just taking, normally, most of these are taking vibration and temperature. That's usually about it. Sometimes there's other technologies that they can take, but most of these right now is just temperature and vibe. So,
Right. So have you seen a use case, and I feel like I have, And there's various companies that make them. Heck, we've even worked with guys in the past. Um, Remember, like with Mike Burdo, for example, he was really good about marking H, V, and A on the equipment, so you were always getting it back in the accelerometer back in the same place. Now, you still run the risk of, it being twisted or rocking or
Sure.
whatever the case is where you're not getting a good solid mount, but at least it got you in the right place. And then there's companies out there too, like CTC, for example, they make those little pucks that you can
Yeah.
adhere onto the machine so you're getting even pull strength. You're not on a curved surface anymore here now, so you're
Yeah.
getting a good pull. I think that helps, but a lot of people don't want to take the time to install those or do the marks.
Yeah.
um, that being said too, with route based, now I understand that the online um, monitoring, whether it be a lot of times with the wired ones, I've seen normally those are going to be, not always, but normally those are going to be single axis accelerometers. And then you run them out to a junction box or whatever, feed them back to a PLC, however that works, as to where the majority of the wireless ones are tracks. A lot of them have an RTD built into them as well, not all. Um, but the issue that I've always seen with running a triax sensor, I think triax sensors work great if they're permanently installed.
Yeah.
I think they fall flat on their face on a route because people have a tendency of not getting them oriented the same way. So even if you're taking it in the exact same location and you actually put one of those little 1 inch pucks on it, I mean, you don't really have any variance on where you put it.
Yeah.
But if you're twisted a few degrees to the side, that signal is going to start attenuating.
Yeah.
Um, Now, how bad is that for the analyst? I
Right.
don't know. I guess I would say it depends.
Uh, As far as orientation with the tracks, it definitely can because that's something uh, in classes I always try to mention. Those of you that are using tracks, you're right. You get it in the same spot every time, even if it's exactly the same spot. You're hitting a target. That's step one. But step two is you've got these three axes, and if I twist it 1 month, my vertical just went to horizontal, or my axial just went to
Right.
horizontal, or whatever. And now our trends are off, and we're getting
And
data
I
to the wrong places in our database.
I hadn't even thought of it from that perspective. I had thought of it from just being off by 5 degrees.
Yeah.
I'd never thought about being off 90 degrees.
Right.
I mean, that
Your direction,
completely,
that's another thing people are, and I was the same way when I started, when I learned about this stuff. I'm like, why are we taking horizontal, vertical, and axial? Like, if we want bearing health, don't we just go to one spot near the bearing, take the readings, and we're good? And that answer is true. Yes, if I only want bearing information. However, if I want to help diagnose, was it unbalanced? Was it a bent shaft? Was it misalignment? Then I need directional, some information because some of those problems on this chart will tell you that look for it to be higher in this direction if it's this thing, or higher in this direction, axial or horizontal or whatever, if it's this
right.
problem. So it does make a difference and orientation wise. And permanently installed, you don't really have that issue if it's done right the first time. But route to route that triax, you do run that risk of did I put it in the right direction? So,
And I I think that's kind of the operator here is if it was done properly the first time.
mhm.
Um, there's a lot of times where, and this goes back to that old saying, well, that's how it's always been.
Yeah,
Well, then it's always been wrong.
right.
Um, yeah, sorry to break the news to you, but somebody
Yeah,
made a mistake, excuse me, and it's just now been accepted that that's how we're doing it. And I've actually run into it with wireless sensors here just recently because these Triax wireless sensors. Well, depending on if it's a top mount or a side mount orientation, you have to tell the software is it top or side mount because it then knows, for example, the z axis of the sensor, if it's top mount, is or is the vertical rather,
sure.
and if it's side mount, well, now it's the horizontal. And if you mount it on the side but tell the software it's top mount,
Yeah,
all your axes are wrong. Now they're going to trend consistently, but
right,
once again, they're consistently incorrect.
right.
And I think that goes back to that's one of the things where if it's installed great or installed correctly, it works great. If it isn't, you're now having to fight that, and you're looking at data going, well, I think it's this, and then you're making incorrect,
Yeah,
outcomes and calls, not because you as an analyst did anything wrong. You
yeah,
just didn't know because maybe you're not the one that installed the sensor. And
exactly.
that's where I think pictures are very helpful. And
Yeah,
if you can't have the picture, once again, putting a person back out there in the field to look at it, I think is paramount. And that's why even with continuous monitoring or remote monitoring or cloud-based monitoring or whatever, I don't think you're ever going to replace that analyst. I think it's still critical that when something breaches an alarm, yep, I can get online and look at some of the spectral data, but the outcome may be, okay, I need to grab my box and walk out here to this piece of
Yeah.
equipment and take a look at it. So
Double check it. Yeah.
um, I think we've talked, probably we could beat a dead horse on this one and go around in circles. Maybe we should get a different perspective.
Yeah. Why not?
So, luckily, we were fortunate enough to line up one of the I would say upcoming guys in the industry, knows a ton, has an immense amount of experience in this, and he has a lot more years to go. A lot of times, you find guys with this amount of knowledge. The unfortunate side is they're a year, 2 years, 3 years from retirement.
Yeah.
We're not going to have this problem with our next guest. He's around for the long haul. Also a fellow podcaster. So make sure I'll have him plug his podcast when he's in here too. Um, Pretty good podcast to watch if you're into nature and hunting, fishing, stuff like that. Good steward of the land, we'll call him. Welcome on, Collin Mann.
Welcome.
Thanks for having me. Glad to be here.
Appreciate you getting on, man. It's been something we've been talking about. We said we wanted to bring on experts. Unfortunately, Stradle
You
had
got the
something come
wrong
up,
guy.
so I had to call you. So
Nice.
you home today?
Working from home today. Yeah,
Good
it's
for
kind of
you.
unusual. I've been traveling a lot, but this week has been light and catching up in the office. So that's been nice.
Good. Are you getting caught up in the office though?
Getting there. Probably
Okay.
75% now.
Hey,
So,
not bad.
yeah.
Not bad at all. Any,
Mhm.
are you home the rest of the week?
Yep. And next week, actually. And then it all
Oh,
kind of ticks off again. We got the SMRP conference I'll be at in Fort Worth coming up. So that'll be the
okay.
next trip. And then Michigan and Ohio after that. So this 2 weeks is pretty nice.
I bet.
Long enough to get back in a routine that I'm going to give up again, a home routine.
Gotcha. Yeah, I think, well, next week I guess I've got to go. I'm home the rest of this week. I got to go to St. Louis and then down to Cape Girardeau a couple days next
Mm.
week. Do some gonna go and just do some touch points with some customers that have bought some vibration equipment over the years and just, stop in, do the whole, make sure everything's going good, take them out for dinner, blah blah
hmm
blah. Just a little
Good
bit of
old
follow-up stuff.
Rivertown there.
Yeah. Yeah, I mean if you want to know anything about gypsum, that's part of the country to go to.
Duck
I mean,
hunting, too. That's what I like about that spot, Cape
duck
Girardeau.
hunting.
hmm
Brett, do you duck hunt?
No, never have.
I've never duck. I think I've probably hunted twice in my life.
Yeah,
Yeah. I'm a
I don't
huge
do a
hunter, but
lot. Yeah.
this is the wrong podcast for duck hunting topics. We'll have to start another one for that.
Yeah, there we go. There we go. And I was, we were talking in the intro a little bit about it's field and timber, and you have to plug that. So
Streaming timber.
sorry, stream and timber. Excuse me,
Yep.
stream and timber. That's why I said we'll let Colin plug that because
hmm
I'm gonna mess it up, and I did,
Yep.
as as expected.
Expected. Yeah.
hmm
But Brett and I have been we've been talking over the last couple podcasts, and then again a little bit before you hopped on here. We've been discussing kind of just as a general overview, route-based vibration data collection versus online continuous monitoring. Whether that be wireless, corded, whatever. And
hmm
obviously, we talk about the continuous monitoring. I think a lot of people, and it's just a matter of not knowing the difference. You get a lot of people that they're like, "No, we have vibration sensors already." Well, no, they have overall those little red light, green light pucks, or even if
hmm
it feeds back to a PLC, it's literally just an overall triggered level. There's
hmm
no dynamic data, nothing spectral to look at. And I've got calls from people in the past, I'm sure you have too. Hey, this thing went up to, I'm making up a number, this thing just went up to, 1.2 inches per second. What's wrong with it? I don't
No
know.
idea.
The
No
vibration
idea.
went up. That's all I know. It
hmm
processed. Maybe somebody, did a train drive by? I mean, there's a lot of things that could cause that.
Hmm.
So I guess with where you're at in industry now, tell us a little bit about what you do now, and then how that kind of, I don't know, transitions in over to that philosophy of, which one's better. I mean, I really don't think there is an answer to that. There isn't one better. There's better ones for certain things, and there's definitely pitfalls in each. So, kind of talk about that if you wouldn't mind.
Yeah. So with this current job, I am supposed to support the route-based data collectors that we sell, as well as the wireless sensors that we sell. And when I started this job, I had absolutely no experience with wireless or remote analysis through those wireless sensors. I had no exposure to it. So I'm rapidly learning about it right now. And I'm noticing the differences between the two, which I'm sure we'll get into, but I'm noticing the benefits of having both. And that's the point I would like to drive home in this conversation is that both are good. They're two completely different things, but when they're put together, they're amazing. So I would say 60% of my time is spent with the wireless stuff. And that's because it's so easy to see data coming in from all kinds of different plants. It's just log in and look at data. With the route-based stuff, that involves traveling and walking around a plant. It's not quite as common for me to do. So I think I spend more of my time now supporting the wireless stuff, which has been fun, getting to learn something new. So that pretty much covers what I'm doing now, just product support for both of those technologies. And I'm
Okay.
doing a little bit of analysis for certain clients. A lot of it is just selling the hardware, kind of getting them set up with an initial overview of the software and then leaving it to them. But some clients actually want support, so I get to remote in and monitor data and kind of write reports for them. And I do a lot of different stuff, and it keeps it interesting.
Do you
Okay.
see very many places that are asking for, like, if they don't have much for predictive right now, like maybe they don't have a vibe program at all and they're looking to get into it? Do you see very much of people that would want to start with the wireless and not even have
Yeah,
a handheld? Is there any sites set up that way?
Yeah, I actually do see a lot of that. And it's a little bit tricky because I'll get on and demo the software to them and show them all the capabilities that it has, that you can auto correlate a waveform and use these harmonic cursors and sidebands. And they're like, well, that's cool, but I don't know what to do with that. So you can actually tailor the program to be very simple. You can actually turn off on a lot of these, you can turn off the dynamic data portion of it
Yeah.
and just let the overalls feed in and rely on alarms. So it actually is a good place to start. Just continuous monitoring. Let me know when vibration increases or temperature increases. And they get emails, and that becomes kind of a program in itself. So it works out well. It's just we can't use the dynamic part of it on those guys.
Yeah. Yeah, no,
And you,
I ask because I've had similar experiences where, you know, Adam and I were talking before we jumped on here that at the beginning it was just route based was about our only options, but with the wireless and the wired, all the different technologies out there, I'm seeing some because I think we all probably said pretty much the same thing, that they work well together. Having one
Mm-hmm.
without the other, it's not that it's not going to be successful. It's just easier and better to have both. But I
Mm-hmm.
have seen a few places myself where they didn't have any program to start, and they said, we don't want to hire a guy and then have to train the guy and then have him leave and then we have to train another guy to collect the data. Like, if we get
Mm-hmm.
these, can we have other people monitor our sensors from somewhere else? And that's one of the nice things, is you can do that.
Mm-hmm. Yeah. With a lot of them, you can use your favorite analyst to log into the cloud and go through your data and see what they think. It's basically just as simple as giving them a login to your account. And it opens up a world of possibilities for getting help from anybody you want. And I've never actually thought about that, but it would be way harder to train a guy on the portable units. Having to learn how to set alarms and set parameters,
Yeah.
Fmax and resolution, and trying to build that whole program through a route based, I think is more difficult than these wireless programs now.
Yeah.
So it's pretty interesting that you brought that up.
I think having that guy embedded in the plant, even if he doesn't have a route-based collector, still having somebody who owns the program is
Hmm.
important. Because yeah, and like you said, you can use your favorite analyst, which let's call a spade a spade. If that favorite analyst isn't you, you're wrong. But
Brett would
but
probably
it
be
also
better.
or I don't know. Brett,
Uh,
Brett, do you want to
Pick your
be anybody's
poison.
favorite
not,
analyst?
not really, but I mean, fun side job. That's about it.
But I
Anytime
do
I've
think
ever brought it up, I've said, pick your favorite analyst. They've never picked me yet, but hopefully someday it'll happen.
they're it's going to come back full circle. It'll
Yeah.
get back to you.
And then
Hopefully.
you'll wish they hadn't.
I think I've seen a lot of and not just vibration, but I've seen a lot of programs just fall flat on its face and fail because you might get whether it be a plant level push or a corporate level push or you know I actually had one plant I worked with years and years ago, and this wasn't a problem. They had a big push for oil cleanliness, and they were going through this whole grease organization thing. And the whole reason they were doing it, I know they had asked me, they said, can you take an inventory of what we need? And we put it together. They had a specific company they wanted to start partnering with to buy oil. And I went back and gave counts to the maintenance manager. I was like, I think we need this many barrels of this to get through. And he goes, yeah, just order whatever you think. Just get like 2 or 3 times more than what you think we're going to need. And I couldn't figure out what was going. Well, that was just a budget issue. They had the money this year, so they're
Hmm.
stockpiling in case they don't have it next year. But those instances aside, I've seen a lot of programs fall flat on their face because even though they get a push to do it, nobody actually champions the program or owns the program.
Hmm.
And I feel like that can be a detriment to the online condition monitoring because if you have an outside analyst doing monthly reports or in your case and mine to an extent, excuse me, we'll set these alarms for people and we keep an eye on them because a lot of this software or the systems you can set up to, hey, if an alarm gets breached, we're going to shoot out an SMS message or an email or whatever. And then that's a whole nother downside to this program. You now work 24/7 because of
Hmm.
equipment doesn't care that it's 2 a.m.
Yeah.
If it's going to have a problem, it's going to have a problem. But these things, they tend to kind of put the onus of the program on a second party,
Hmm.
i.e., you. Um, and then I feel like the programs kind of fizzle out because nobody at the plant is driving the program. Do you see that
Hmm.
problem?
Oh yeah, it's happened a ton of times with these. But then I see the opposite, and I really want to tell this story because it's fresh on my mind. I just got off the phone with this guy. We did an install last week, and this guy that's championing this program has already found 3 different defects with these sensors. One was a bad coupling. He sends me data from the sensor, which I have access to anyway, but I wasn't watching it. Sends me data, then sends me what he thinks is wrong. Then shortly after that, sends me a picture verifying that what he thought was wrong was the problem. It was a destroyed coupling. It had a
Okay.
big 3X in the spectrum, and it was one of those. I think I would call it a Woods coupling, but 3 fingers on each hub with the little insert. So the
Mhm.
3X is from the 3 fingers on the hub. So I got to see all that come full circle. So this guy's using the sensor, analyzing data, going out checking things, verifying, and then putting events in the software to show what he did. It's a program that's working perfectly. But to answer your question, there's tons of people that install this stuff and then neglect it. They don't set alarms, or they set way too many alarms and they become a nuisance, and you just ignore them. It's like anything else. The program is not going to work if someone's not monitoring things correctly and doing maintenance on it. That's the other thing. A lot of people will argue wireless is bad because you're not out there walking the route, putting your hands on things, looking. Well, you still need to do that with wireless sensors. You need to go check them all, make sure they're all on there. Um, Reorient things if they're magnetically mounted, make sure that they're all in good shape, change batteries. So there's still going to be a route to walk, and you still need to put your hands on things and look for safety issues and things like that that you would walking a route-based program.
Yeah, I totally agree. And, it reminds me of a lot of the other things that are, I guess you'd call it wireless, but like even in lubrication, single point lubricators, these auto lubers, it was the same thing when they came out. Is people are like, oh, cool, we don't have to send a luber out to the machine. And we found out quickly, yeah, you do. You still need somebody to go check these things because they're not flawed. They can't tell you when there's something wrong with them. And if they get knocked off or something breaks or the batteries go bad or whatever it may be, it's a very similar type thing. Um, you might think, well, then why even have them? Why not just have the guy out there? They do save a lot of time, but you still need a certain amount of time set aside to make sure that somebody's out doing rounds. Let's take a look at these things. And in the beginning, let's verify. We got a data collector, for those sites that have both. Let's go out when this thing said it looks like we've got a high 1x. Let's verify. Is it a high 1x or was that from something else? And let's double check it. But yeah, I think that needs to happen in the beginning. That's the first stage, I think, is work them together when you can.
Exactly. And you brought up a point that I wanted to make as well. Anytime I see an alarm with a wireless sensor, I'm always going to recommend that someone go out and collect data with a data collector to back up what we're seeing. You don't always have to do that, but it's a good idea. One reason for that is that these wireless sensors are almost all triax sensors. So in my opinion, you have one plane that's pretty reliable and then two planes that are a little bit compromised, in my opinion. The one that's the reliable one is the one that's the z-axis pointing directly to the bearing. To me, that's the most dependable. The other two are kind of pointing out in free space. They're not useless, but they're not going to be quite as effective at picking up defects. So I would rather go out there with a single axis if I know there's a problem and take a vertical, horizontal, and an axial and get 3 really good readings with a portable data collector. So I always want to back it up with a portable unit to verify certain things because we only got one sensor on one point, and it's going to let us know something's there, but we really should get some more data on top of that.
Yeah, absolutely.
What's your opinion, Colin, on, well, not really move on, but what's your opinion on using triaxial sensors for route-based collection?
I do like them for the reason that it saves time, and those two planes that are compromised, I don't not really like using that word, but they're still good for trending. So we're still going to see a vertical energy increase or axial, depending on how you orient these things. They're not useless. So if you see something trending up, maybe we move that sensor a little different way, or we pull out a single axis accelerometer at that point and take some other data. So
Sure.
I think they have their place, but for troubleshooting and pinpointing defects, I probably wouldn't use a triax. But routine route-based stuff, I think it's great.
The issue that I've seen, and maybe I'm the only one, but the issue that I've seen is it kind of goes back to a lack of training, but you'll have the data dog, if you want to call them that, that's going out there and getting this data. They tend to not get the sensor oriented back correctly.
Mm-hmm.
Or like Brett had mentioned earlier, and it's not something that I had even considered. Not only do we have the issue of it getting, knocked off, 5, 10, 15 degrees where it's attenuating signal, they might put the thing on full 90-degree shift. And
Mm-hmm.
now your axial's your horizontal and your horizontal's your axial.
The trends are
And
all messed up.
yeah, the trends get all screwed up, which is why I personally am not a big fan of using tracks for route. Oh, but it's not because of limitations of the sensor or the technology. It's
If
the
you use it
human
right,
element.
yeah, if you use
Yeah.
it right, it's good.
Yeah, and I think the human element is what really makes that fall flat on its face. And that is not something that, I mean, because if a guy just doesn't care, you can't train care into somebody.
Yeah.
I'll tell you something very interesting. A little bit about me. A triax wouldn't really cut time for me because when I collect route-based data, I only take one radial reading at a 45-degree angle most of the time when I can, and one axial per shaft. So when I
Okay.
was doing route-based stuff, I minimized my time as much as I could in the field. So I took the bare minimum amount of data that I could get by with. And that's what we came up with, was one radial per bearing and one axial per shaft. So that triax really isn't going to speed me up on route-based stuff, because that's how I collect data. A lot of people would say that's bad, that's dumb, but we were able to see defects coming on, and if we did need more data, we saw a problem, we'd go get more.
Yeah.
But on the typical route-based everyday data collection, that's what I was doing. And we typically had a 2000 hertz F max, so the data was real fast, and we wanted to minimize time in the field. So then if problems came up, we would adjust parameters and take more data as needed, but not getting all that data all the time.
Sure.
So a little interesting fact about my style. It's just me, though. It's
And you're
not necessarily the right way to do it.
I've actually come across other sites that's how they collected data too. Was like they'd just pick one horizontal and they'd ignore the other ones, and they'd get one radial and, like you said, one axial per shaft. And that does work when you have the time for somebody to go out and say, okay, we've looked at the initial readings. Something's weird on this one. Now we need to go back out to this handful of machines that we got weird readings, and then do horizontal, vertical, and axials on those. But
and a lot of times there's two of those readings that aren't real reliable anyway. Like a TEFC motor, there's only certain places you can get good data.
Yeah.
Like you're really not going to get an axial on the outboard bearing or the opposite drive-in. There's a fan cover there. I mean, a lot of people get it on the junction box or on the foot, but how good is that data? There's usually one spot that's pretty good to get data on any particular point. So I think the other two readings are kind of compromised anyway. Like taking data on a cooling fin on a motor. I mean, how good is that really?
Well, why can't we just take it on the guard?
You could. It'd be noisy.
People do it.
It happens a lot.
Do they do it successfully? No, but they do
it. And while we're at it, let's make sure the magnet isn't tight.
Yep.
Right.
And don't line the two bars on the multi-surface magnet up with the curve.
No.
You want to make sure they're cocked at about 45 degrees.
And since we're saying what not to do, go ahead and throw that magnet on there and hit the button to store the data.
Oh, yeah.
Don't have settling time,
Do not let that sensor settle. It is
Hey,
a waste of time.
In the field, don't do visual inspections. You don't have time for that. Don't do that either.
Another picture. I'll tell on myself for one more thing too. While we're talking about the two rail magnets, I always use a flat magnet for everything, and a real light, like 15, 20 pound pole, very light magnet. And that all goes back to the speed thing. I want to be able to roll that thing on real gentle and get it settled down real quick. So the stronger magnets tend to smack a little harder, and you got to kind of wait for that ski slope to disappear. So all of those little things go into being as fast as possible and still being, still getting good data, but collecting data very, very quick. And that comes from the service industry that I came up through. We wanted to get as many jobs as we could done and still be able to see defects and warn customers when things were starting to go bad. So it was up to us to get as much work done as we could so we could make more money. Yeah. That's kind of how I was trained. So I'm trying to get rid of some of that way of thinking now that I'm in a different role. I'm trying to shift my way of thinking into what most people would do. I'm trying to just tune out my old service industry mentality now. But it's hard to adjust.
While we're on that point, I mean, because clearly this whole thing is, unscripted. I kind of had an idea of the route I wanted to go to begin with, but I think this is a good, jumping off point, if you want to call it that. So the people listening, what are some good tips and tricks of route-based that you've found over the years? Just even the slightest minutia that'll just make people's job easier, quicker, more effective. One that I have that I always stress to people is when you roll that magnet on and you roll that magnet back off, always roll it clockwise. Because otherwise, over time, that magnet starts to loosen up if you start rolling it counterclockwise and you don't catch it, and then you start getting ski slope.
You taught me something.
Yeah. I wondered
I just learned a tip.
Yeah.
I never
But
thought about that. But
but
when
that's
I,
just one tip. I mean, there's thousands of them. What are a few that you have?
yeah, that's very interesting. When I roll the magnet on, I'm not really rolling per se. I'm touching the bottom and gently laying on. So it's like a
Okay.
bottom up kind of roll. And I'll give you an example of why I do that. The very first time I ever collected data, I was just a data dog, didn't know anything. And this guy that I worked with had me tag along, and we split the route in half. And I collected data, he collected. We came in, dumped the data, and I'll never forget. He was looking at the computer, and he turned around and he said, "All of your data is bad." I'm like, "What are you talking about? I took good data. I did it right." He's like, "It's all bad." He's like, "Look, every one of my spectrums was a ski slope and nothing else." And he was very calm and very patient. He said, "When you put your magnet on, you smacked it on and pushed the button. You were trying to get done real quick." I was like, "Yeah." And I remember intentionally popping that thing on. I kind of liked the sound of it. It was fun to snap that magnet on there and immediately push that button. And I had to go back and recollect all of that data because I smacked the sensor on. I didn't give it time to settle, and every bit of the data was trash. So that's why we're bringing up rolling the magnet gently to avoid exciting that sensor. Not to make this a sales pitch or anything, but the product that we sell, Beta Vibe, actually has live data on the screen. So you actually see the spectrum and the waveform. So when you put that sensor on, that waveform goes haywire and you can watch it settle out. You can watch the ski slope disappear and know when it's safe to push that button. So that live data collection screen is a game changer for that. But yeah, as far as tips, always roll the magnet on gently or place it gently. And again, that's why I like a light magnet, because it's almost impossible to do that with some of those stronger magnets. I've seen people collecting data with 40, 50 pound magnets and, big old round things, and they're pop, and you got to wait forever for that to settle out. That's definitely one of them. And gosh, there's all kinds of tricks about data collection that we could get into, but specifically that one is just that little story to kind of put it in perspective there. The
Yeah.
Well,
importance of being
what
gentle.
you mentioned, I can kind of add to as well. I've seen some of the larger, and the 40, 50 pound magnet, we're of course talking about the magnetic pull, the force, but the weight of them too. We actually have data saying that, in some of our training saying that the transducer or magnet, the whatever you're attaching to the bearing to take the reading, should be no more than 10% of the weight of
Mm-hmm.
the actual bearing, which in most cases we don't hit that. But there are some small pillow block
Mm-hmm.
bearings where if you put one of those large magnets on, you've gone beyond that and you've affected it, because
Yeah.
you go into natural frequencies, and we can go down that rabbit hole too. But just a quick point on why that happens is the natural frequency of something depends on the mass and the stiffness. If we throw that big
Mm-hmm.
magnet on there, we could have changed the mass or the stiffness of that bearing, and we might have
Mm-hmm.
shifted that natural frequency to where now we're in resonance just because we put our transducer on. So
Mm-hmm.
it's a good, I'm glad you
Yeah,
brought that up. That's a good point.
it's really interesting. Yeah.
Size of the transducer can affect our readings for sure.
Mm-hmm.
So talking about natural frequency, just a little anecdote, if you want to call it that. So I was up years back, and I think this is going to segue into one of Colin's strong suits, which is fan balancing. So I was up in Northeast Iowa working at a plant. It's been years back, and I got a phone call from another plant that just happened to be right behind the plant that I was working at. And they're like, "Hey, when are you going to be up in the area?" And I'm like, "I'm literally next door. I can run over on lunch." And they said, "We have a fan that needs balanced." Okay, I'll come over and take a look at it. Why do you think it needs balanced? That's always my first question, because how many times have people called for a fan balance? Well, why? Well, it's shaking. Well, good for it. That doesn't mean it needs balanced.
Mm-hmm.
So I went over there to take a look at this thing, like over a long lunch break. And I said, let me come over, and I want to grab some data on this thing and see what's going on. So I walked up there. It was set on a platform, maybe a foot off the ground, and then the fan was maybe 4 or 5 feet to the top, up on top of the A-frame. So, and they're right, it was shaking. It was shaking real bad. And I walked up
Mm-hmm.
there, and I said, "Let me just do a quick check." Well, at the time, no longer, but at the time, I was about 220 pounds, and I just walked over and at the time I was using a VB7, and you could put the time waveform in live,
Yeah.
similar to the Beta Vibe, but much more rudimentary. But you could at least watch a time waveform. So I
Mm-hmm.
threw the time wave on, and I'm watching my peak to peak, and I just set it down, and I climbed up on the A-frame, and it just flatlined,
Mm-hmm.
gone,
You added
vibration gone.
damping and
Yeah,
mass.
yeah, I added a lot of mass. I would add even more mass today. I'd probably take it into a resonant harmonic at this point.
Bent
Um,
shaft.
pretty much. So I told the guy, I said, I'm happy to help you out here. It doesn't need balance. Well, how do you know? Well, because I just proved to you. The
Watch this.
vibration's gone. I never balanced it. And he was dead set on having me go in there and balance it. So I went over after I got done at the original plant I was working at that day. I went over and got a couple tractor weights from Tyson's. I don't know if you have
Mm-hmm.
Tyson's out in Indiana. It's like a Tractor Supply or a Baumgars or something, a
Supply.
Farm and Fleet, whatever.
Mm-hmm.
So I went over and got a couple tractor weights, took back over there, set on the platform. I was in this plant about a year and a half ago. They're still sitting there,
Mm-hmm.
and they've never done anything to fix the
When
resonance
it's
issue.
not
But
on a VFD, that's kind of what you have to do. You have to get
yeah,
creative and tune that out of it.
and
Yeah.
we did in a very redneck way tuned
Mm-hmm.
out of the resonance problem. But the reason I bring that up is because we talk about route based collection, and there's a lot of companies that make a balancer only.
Mm-hmm.
Um, I always am a little bit hesitant when somebody calls and says we need a balancer only. Okay, how do you know it needs balance? Now, there's definitely a place for them. Like if you already have a pretty robust analysis program and you just need a unit just to do your balancing, I get it. But if that's your only tool, that's a bad tool to have because people
Mm-hmm.
are going to try doing balance jobs and then they get mad. I've had people call me after balance jobs and I'll say, hey, do you want me to dig into, do some analysis on this first? Nope, just balance it. Okay. So you will, and then they call you 3 days later, still shaking.
Yeah.
Yeah, I
Mm-hmm.
know.
That,
That's
that's the problem. That's why the first step in any balance job should be verify that it's unbalanced first. Because
Mm-hmm.
I've been called, like you said, that's everybody's first knee jerk reaction is this thing's it's a fan. It's vibrating more. It's probably out of balance, and a lot of times it might be. But I've got pictures that I could show that are really hilarious because they call you to balance these fans. There's cracked welds. None of the hold down bolts are doing anything, or they're sheared off, and you're like,
Mm-hmm.
it could be balanced too. But before I ever even tried the balance job, you need to fix these things because you will chase to do balance job, we need good phase data, or most
Mm-hmm.
types we need good
If
phase
it
data.
doesn't lock in, you're done. You're
Yeah, you're
toast.
going to chase your tail. And that's every time I've opened up a fan and I found more than like 4 or 5 weights. I'm like, that guy was probably chasing phase. It was all over the place. And the box doesn't know. Most of them are, well, they might have some that are better, but some are stupid and they're going to say, I assume the phase is good. And what you're giving me
Mm-hmm.
phase wise says you should put it here. Now you should put it here. Now you should put it there. When in reality,
Mm-hmm.
it's moving phase and it's hard to do those jobs.
Yep, exactly. That's the unfortunate part about balancing is I absolutely love balancing. I think it's super fun. The unfortunate part is
you're on your own, Colin.
I almost never get to do it because every time I show up for a balance job, we
It's
find something else.
yeah.
It's usually run out. If I have a high 1x and the balance isn't working, it's going to be run out. The only time you really get to balance a machine is if it's brand new, they just installed it. You typically need to go through a field balance process, even though it was balanced in the shop. And then the other time would be if there's significant wear. So we're trying to make up for uneven wear. Or the third one is if the plant demands that I balance a dirty fan, which I don't want to do. I will always tell them it doesn't need balanced, it needs cleaned. There's dirt stuck all over it. Clean it, it'll be fine. It was balanced before, it'll be balanced again. And
Yeah.
there's no time for that. And I'm like, you want me to balance this dirty, knowing it's not going to last? And they say, yes, we just need to run. I have done that many times. And it works temporarily. It'll get me home for the night, but it doesn't last. When dirt flies off, all of that is gone. And to your point with multiple weights, that's another reason those may be on there. is because they've balanced it dirty so many times. There's just weight all over the place.
Yeah.
So it's kind of frustrating. If I get called out to balance, I'm ready to balance a fan and, draw a vector out or use my calculator. And I know I'm not going to be able to. I'm going to find some other issue that gets fixed, and we won't actually go through the balance process. It was very frustrating for me because for a while, my job was to train field service guys in balancing, and I would take them out. I would use one guy at a time and say, any balance job that comes up, you and I are going to go do it together until we get you comfortable. So we'd go out 4 or 5 times and not get to balance because we would find something loose. That phase is moving around. Well, we got looseness. Let's find it. You get out a dial indicator and a pry bar or a hydraulic jack and you find the looseness. And you point that out and we go home without balancing. Or we find a dirty fan or something with run out, and they learned a lot from that, but it was really hard to teach them the actual balance process because it's so rare to find a situation where you actually have to balance in the field. In the shop, it's totally different. You do it every single time you send out a rotor or a fan wheel or a pump impeller. But in the field, it's a lot more challenging.
Yeah, agreed.
On the note of cleaning too, and this would be another one of those tips and tricks, if you want to call it that. If you are, and I would agree, not always, but a good chunk of the time, hey, this thing's out of balance. You check vibration data. Yes, it is out of balance. It's because of buildup or dirt or whatever the case is, product on the blades. So you'll send somebody out to clean it. If you're not going to clean it 100%, don't clean it at all.
Yep.
Yeah.
Because, and I can't tell you how many times they'll say, well, we cleaned it, now it's worse. And you shut it back down, put a lock on it, pop the inspection door off. Well, they cleaned 3 of the 8 blades. Well, no wonder it got worse, or they cleaned the
clean the top of
face.
the blade, but not
Yeah, but not the back side or something. I see it all the time. And it's like, it's attributed to go drive, you live on a gravel road, Brett. What's going to happen if you park your car in your driveway, take the garden hose, and only clean out the bottom half of the gravel
Yeah.
dust?
The car is going to shake like hell.
Things going to shake the shit out of you driving down the road. And people just can't get that through their head. And I'll tell them, it's like, go out and clean it. And before you put it back together, I want to visually inspect this thing.
When I say clean, I mean hydroblast.
Yeah,
Fully
you got to clean it, not just hose some of the dirt off. And that, and the other issue I've run into is especially on fiberglass fans. Depending on, I mean, you get into like a scrubber fans and stuff like that, they're pushing a pretty nasty shit out of the stack. And you'll look at these things and you pop the inspection door, and I've been asked to balance them. I'm like, dude, it looks like a fucking piece of Swiss cheese. You that, and on top of that, and this is just and maybe this is coming more from a liability, not reliability, but a liability stance. Fiberglass fans, I won't balance. That's just a me thing. Or coated blades, if they got the fiberglass coating on them or the plastic coat or anything, because when you go drilling into those things to put a weight on, it breaks that coating, and now you've created a stress point in the fan or in the blade. Stainless, aluminum, steel, not a problem. You don't really have that issue. But when you start cutting into fiberglass, it tends to make a weak spot. And I guess I don't want the legal ramifications when that thing explodes.
I'll give you an interesting story about that. We had to balance acid fans on the pickle lines at steel mills a lot. And those fans are fiberglass wheels. And to put weight on them, we had to drill a hole, put a stainless bolt in it, and the acid will even eat through the stainless. So we had to cover the bolt head like on both sides with epoxy. So it was one of the most challenging balance jobs I've ever done because you had to pick a weight and then weigh your epoxy because by the time you apply it, it's going to have an effect. So that was a very long process, a lot of little calculations that went into that. And I still don't think it was a real good way to do it, but that's what the customer wanted to try.
Have you ever had to
get really tricky?
Weld the weights on or use welding rods to create the weight? Have you ever had to do those?
Oh yeah, tons. Yep.
Can be challenging.
A lot of times we'll take a plate that's the weight, but then you got to weld it on, so you have to account for the weight of the rod, and that really only matters a lot when you get into higher speeds, or you're trying to fine tune the last couple runs and you're really trying to get in spec. Then you're going to start to worry about those little minute differences. But another fan that I've balanced quite a bit is like a 30,000 pound wheel, and it has a sensitivity of 1 pound per mil. So if I show up and that thing's shaking 10 mils, I have to weld 10 pounds of weight onto it. So that one's so big that I'll cut my weight to like 9 pounds, 9.5 pounds or so, and then just weld a whole bunch on it, and I know I'm good to go. It's slow speed, so it's not that sensitive. So I don't always have to weigh out my welding rods and things like that. But on some fans, it really does matter. You're dealing in grams, so the length of the welding rod goes into effect with that.
Yeah,
Sure. So when you do balance jobs, I mean, sometimes you don't have an option, but if you had your druthers about you and you have your, you get to pick 100% preference, would you rather use one of these new high-end balance programs that tells you what to do, or would you rather go back to the old vector
I
method?
would rather vector. I
Okay.
think it's easier. Now I do use the calculators if they're in there. Like Beta Vibe has a built-in balance program that I'm supposed to be fully aware of. It's my job is to support that. So I know all the ins and outs of it, and I tend to use it because I know it. But
Mm.
back in the day when I started, I had a CSI 2115, and all we did was collect peak and phase with it, and we would write those numbers down and vector it out. So I got to learn the vector method, and people overcomplicate the vector method a lot. And even in vibration school, I think it's overcomplicated. Basically, what it comes down to is you plot your first line, your first run, and then your second run, but don't connect. Don't draw a triangle, just draw a vector, 2 lines. And once you've established that initial run and trial run, the goal is to close the door. So if you don't connect those and just teach someone close the door, they now know what direction to move the weight. And based on the length of the lines, they know if they have too much weight or not enough. It's extremely simple if you teach them that close the door method. So if my first run is this long and my second run is this long, I got way too much weight. Back it off, close the door. I need to rotate this way with my weight if you're looking driver to driven. So that's kind of how I learned, just close the door method. You can almost just draw it in the dust on the side of the machine. Go, okay, this run was 2 mils. This run was 4 mils. So that line's twice as long. I need half the weight and I need to rotate it this way.
Okay.
So just in the simplest sense, you can quickly teach someone to vector balance like that. Now, the proper way to do it is to measure the angle with a protractor here to know the exact number of degrees to move your way. And you measure the lengths of the lines and do some division to perfectly calculate the correction weight. So there's 2 ways to do it. There's kind of the eyeball method, close the door, cut the weight in half-ish kind of thing. And that typically works to get a fan in spec and go home.
Huh.
Like, okay, I'm going to back the weight off a little bit, move it that way a little bit, and we're going to go home.
Huh.
So that method kind of works most of the time. But anyway, the new calculators and programs are all pretty sweet. Now there's a lot you can do with them. And I prefer to always record a coast down. Every time I balance, I want to record the coast down right off the bat because it tells us a lot. Number one, it will identify any natural frequencies across that speed range. So if I kill the power and the amplitude immediately drops and levels out all the way through, I know I'm in a natural frequency. That's not an imbalance. An imbalance should be linear, dropping over time. And it will show me all those natural frequencies as I come down in that run. So if it's on a VFD, I can tell the client, hey, this speed range right here, may want to lock it out on the VFD or avoid that speed. But the other thing it does is it shows me my lag angle. So I take my running speed phase minus the slow roll phase, and that's my lag. So I can use that to quickly adjust. And a lot of times you can one-shot the fan. You don't have to necessarily throw on a trial weight. If you're good enough at guessing the amount of weight, you kind of know where to put it. And a lot of times you can one shot and go home pretty early, all based on that coast down test. So
Okay.
when I'm balancing, I like to at least have that function on my data collector to look at that. So little tip there.
I'd never thought of doing a coast down prior. I mean, is that something you
Always.
teach when you do balancing, Brett?
What's that? Do what?
The coast down prior to.
No, because not all the data collectors we have had that capability, or it was something that you
Okay.
had to add. It kind of depends
Yeah.
on the data collector you have, but
Yep.
no, I think it's a good idea because I mean, anytime you got a machine down, if you can collect some data that can give you the natural frequencies, that's be it a bump test while it's down too. That's another option you could do. But
Right.
yeah, it's nice to know because that can account for some of the things that you're seeing as an analyst. So yeah, no, I think it's a good idea. Probably should.
And then the other tip is once you've balanced a fan, you now know the sensitivity and the lag. Those are the two pieces of the mystery that we're trying to find when we're going through that balance process. That's what the math is doing in the background, is trying to find those two pieces of the puzzle. And once we've done it, we now know it. So if we record the sensitivity and the lag, every time we come back to balance that fan, we know how much to put on and right where to put it based on those initial readings. So the example I gave earlier of the fan at the cement plant, it's 1 pound per mil with no lag. So my high spot and my heavy spot are the same. So when I take that data, I know right where to put the weight and I know exactly how much to put on. And I've done it many, many times at that place. And they think I'm like very, very special, very smart. Collin has to do this. He's really smart. No, it's not that at all. It's you have the most simple, basic fan on the face of the earth with the simplest sensitivity and lag scenario. So,
Gotcha.
yeah, I'm a balancing nerd. I love it.
So do you still do balance classes?
Kind of, yeah. Ludeca does balance training, and we have a guy that does them right now that's very, very good at it. And I was able to go with him a couple times, and one time he actually had flight issues, and I had to do the first day on my own. I think everyone was like, "Oh my gosh, Collin's gonna be so mad. He's got to fill in." I'm like, "No, I love this. I'm very excited about this." So I got to teach once, but that's something that I'll be doing a lot more in the future. I think with Ludeca is balance training because we do a lot of it,
Sure.
and Gary's really good at it. So I've learned a lot from him too. He's got little tips and tricks that I've never used. So I've gotten even better working with him. So I'm pretty excited about that.
Well, and Gary's got to be just a few years from retirement, I would guess. So
Yeah,
you see that this will become your role.
it's kind of looking that way, and I'm kind of hoping for that. So
Okay.
yeah, looking forward to doing that. I love teaching. I've always enjoyed it. But it's just there's a lot to do. I got a lot of different roles here, so it's gonna have to figure out how to balance all that in the future.
Best of
But
luck.
I do some consulting too. There's some former clients of mine that have reached out to me since I've moved, and Ludeca's never been real big on service work, but we're doing some more of it now, and I've been able to go out and just do consulting on these balance jobs. So I'll bring
Okay.
my equipment and I'll take the readings and run the math, and you guys weld the weights on. I don't get inside of it. I just do the nerdy stuff in the background. So that's kept me pretty sharp on it. I've done 4 or 5 of them. I got another one coming up here in October to do. But I think those are just going to be dirty. Probably won't get to balance them. The ones in October, every time I've looked at those, it's been the shiv is packed full of material, and then some of that will bust out of there. So you got all this material swinging around on the inside of the shiv. I'm like, clean that out, and we're probably going to be good. And it usually is at this place. So we're going to take guards off and clean and take readings and probably be done.
And I always found the quickest way because typically, we're aligned to a G 6.3 spec. Now,
Mhm.
sometimes that'll change, but that's the majority of them. So I'll throw an accelerometer on there. Let's take some readings. Heck, if we're under 0.248, what are we doing here?
Hmm.
It's because I think it's kind of akin to doing an alignment. For example, once you're within an acceptable tolerance, why are we trying to get it closer? There's a reason we have
Hmm.
tolerances. You're never going to balance a fan to zero. Well, I shouldn't say
Hmm.
never, but I'd love to see it.
I
You're
worked with
never
guys
going to
that
get,
thought they could. It made for
yeah,
some long nights.
I, you're never going to get an alignment to zero.
Hmm.
These aren't. So once you get it to where it's in the green, let's pull our let's pull our shit and go home. And
Yep.
people, we so Brett and I were talking about a guy before you jumped on that we used to work with who was meticulous would be the politically correct word for it.
Hmm.
Anal retentive is what I would call him. And that guy would nitpick, nitpick, nitpick. I know one day I was actually helping him on a balance job. It was on a boiler fan. And we spent it was over a day. I think it was probably a day and a half. We worked on this fan, couldn't get it, couldn't get it, couldn't get it. Well, then after we messed with it forever, and of course you can't, it's very hard to see it where it's at because it's up on a boiler inside. And you're elevated and up on a platform, so it's hard to get in there. Kind of working around sideways. And he finally, after a day and a half, he goes, I don't know why we can't get this. They dropped it when they went to put it in and it bounced off the concrete, but I didn't think it was that bad. And I'm like, oh,
Hmm.
I'm gonna come after you. I mean, and it's hot. I mean, we're in a boiler room up on the ceiling. I was not in a great mood anyway.
Hmm.
But yeah, just things along the way that I found that you pick up things you should check before you even start because you
Hmm.
might save yourself a ton of trouble. And it all goes back to that very simple. Hey, we need to balance this fan. Okay, why does it need balanced? Or why I should say, why do you believe it needs balanced?
Yeah.
Even if
And if
you take data and you see 1x, it still doesn't mean it's
doesn't
unbalanced.
necessarily mean that, right?
A lot of times it's run out, and you typically can't overcome run out with a balance process. Sometimes you can, but if
Yeah.
you have a bent shaft or an eccentric bore or a pulley that's got run out to it, you're not going to put enough weight on that machine to counteract that swinging around of a pie-shaped piece of the rotor. But it
Sure.
looks like unbalanced, and it actually is unbalanced, right?
Yeah.
If you have an
But
eccentric bore, your center of mass is off, but
yeah.
your little balance weights aren't going to touch it. So
And
the
what
best
usually
thing to do.
happens with those is you might try to do the balance job for eccentricity, and it might bring the amplitude down in one direction when on the
Mhm.
other direction it's just double. So
Yep.
that can go hand in hand. So yeah, figuring out that's what I said before. Verification that it is actually in balance important because, like you said, 1x that peak that's the one all vibe guys dread is because I see an increase in my 1x. There's a long list of things it could be: bent
Mhm.
shaft,
A lot of
eccentricity,
times
looseness.
misalignment.
Misalignment can show up at 1x. Yeah, there's a lot of
Mhm.
things. And, that's where doing a little more analysis, sometimes that may be cross-channel phase analysis, or it may be something that you can do out in the field visually, or other, finding out where the readings are highest in the axial or the horizontal or the vertical. But there's a lot of things we can do to verify. And sometimes a visual inspection is all you need. But it needs to
Mhm.
be done so that we're not wasting our time, which we end up doing sometimes, trying to troubleshoot one problem when there's actually multiple problems or something entirely different.
Mhm. And the best way to rule out run out is with a dial indicator.
Yep.
Set it up, check a few things, and rule it out right off the bat. So a lot of times I will start a balance process by using a dial indicator to check multiple things. If it's a belt drive, I'm checking both shivs. It takes just a second to take radial run out readings and
Yep.
then take them on the coupling hub, on the shaft, and then I'm done. I know everything's straight. So now if I see 1X, it's probably unbalanced. It's probably going to work. So
Another thing
I
you
taught
can
field
do,
service guys that.
another thing you can do while it's running too is using the cross-channel phase. With a cross-channel phase, if we're taking a horizontal reading and a vertical reading on the bearing closest to the thing that might have the eccentricity, because they're 90 degrees apart from horizontal to vertical, we should get approximately 90 degrees phase difference. But when it has eccentricity, what often happens is instead of that 90 degrees, it's actually 0 or 180. So it's not what you'd expect to see. That's another way you can verify that it's could be eccentricity as well.
Yeah, I've heard of people doing that. I've honestly never done that. It's probably something I need to brush up on and get better at, but I've heard a lot of people do that. And like a bent shaft, your axial readings should be, I'm going to get this wrong. If you have them pointing the same way, they should be 180
Yes.
out.
Yep, you're right.
I always get that wrong, but a lot of people talk about that too.
Well, and visually, if you try to picture what the bearings are doing, if you have a bent shaft, is they're trying to follow the bend of the shaft. So if you picture that in your mind, the tops and bottoms of those bearings are going to try to follow the bend, and we're going to have 180 degrees out, in and out, either top and bottom, either way. So sometimes that's helpful as that phase analysis, but also, even our amplitudes, because we're going to get that unbalance if it's bent shaft because, like you said, with eccentricity, it is an unbalanced situation because the shaft's heavier to one spot, but we can't balance that out. So looking at those axial readings and the amplitudes of those sometimes will help that too. But yeah, no, it's all good stuff because this is all stuff, people, they want answers for. That's what they're coming to training for. That's what they're, trying to figure out. Hey, I just bought this data collector and I'm going to do balance jobs. How do I do it? This is a good start for people to, and to talk to you. I mean, I've picked up a few things too that I like vectoring. I just never put the time into it. I made it overcomplicated, just like what you said, and was kind of scared for it. So I'm like, you know what? I'm just going to trust this box. And usually most of my balance jobs were that, but the way you described it, it does make it sound so much simpler. But
close the door and drive it to the center.
Absolutely. Yeah. No, I like that.
Speaking of these pre-checks, one last thing I just want to point out is one tool that I don't think can be overlooked is a strobe light.
Yeah.
Oh, yeah.
I've found a lot of run out issues. Now, it's got to be enough that it's visual, obviously.
Yeah.
If you've only got 1 or 2 mils, you're not going to see it. But if you have axial run out on a shiv, for example, you're going to, if you've got 5/10,000ths, if you freeze that thing and match the speed and then either advance or retard that thing by 5, 10 cycles per minute, you can see the thing walking. And I've always said, if I could only have one tool, give me a strobe light. I can find a ton of stuff with a strobe light.
Just
at the very minimum,
don't
I think
touch
all
the
vibe
part.
guys should have.
What's that, Brett?
I said at the very minimum, I think all vibe guys should have them. If you're out collecting data, I think you should have one because it gives you the speed, which is very important for analyzing our data. All the multiples of running speed and the multiples of other fault frequencies. I got to know what the speed is to begin with. So speed acquisition, but just like what you said, visual inspections. I can read the coupling. If I can have access to the coupling, without shutting it off to figure out which coupling model this is, you can even read stuff on there or see that there's cracks. I've seen those omega couplings where you slow it down, you freeze it, and you can see splits in it where it's dry rotted or something else is wrong with it. Or you detune it, like you said, 5 to 10 RPM above or below, and now I can watch the coupling hubs were not set right, and they're actually doing this, back and forth. There was too much gap or something.
Well, and just something as simple as, one, on the coupling, you're completely right, because I've checked these before where you'll shut it down, lock it out, and do a visual inspection. We don't see the cracks because there's no rotating force there to make them appear. And then additionally, one thing that, and I've used this before, and I actually got into an argument with a guy one time. It was on a chemical process, and they had to maintain vacuum on this system for venting issues. And it wasn't very much vacuum, but they had this fan up on the ceiling that they had a motor fail on it. They replaced it, and it was in a cradle, total pain. And they kept getting alarms because they were losing vacuum on this system. So their diagnosis solution that they were doing is they were opening the vent doors on these vessels, and then they were taking a Kleenex and waving it over it to see, if it was pulling or blowing. I'm like, whatever, it's effective, I guess. I said, I think the fan's turning backwards. No, it can't be. Well, it can be. So I got up in a scissor lift, went up there with a strobe light, and you guys know this, but food for thought, anyone listening, if you ever need to check rotation with a strobe, set your speed, retard it. That's your rotation.
So
Advance
slow it down.
is against rotation. So Anyway, so I went up there and checked it, and I said the fan's backwards. You know, well, we wired it back up the same way. No, I don't care. The fan's spinning backwards. I said we need to jump some legs, and they said, well, we can't get to it because I learned I can't use the word I want. Motor junction box was inaccessible from where it was hanging in the cradle, so they couldn't get to it to reverse the leads. I said, just go down to the bucket and switch them. You can't do that.
Yeah.
Yeah, you can.
Yeah, you can. It's all the same thing at the end. But then L1 is going to go to L3. I don't care. It's a
Relabel it.
label maker tag. Just print out a new one. Who cares? But anyway, yeah. So
Mhm.
I think there's a lot that can be done with a strobe. Um, Now, is it the be all end all? By no means. But I think it's a
Mhm.
very handy tool checking for belt cracks, slipping belts, coupling
You can
issues.
even
You find
read. You can even read a
soft
part
play.
number off of a
Yeah.
coupling hub or a shiv
Yeah.
Exactly.
without
I
shutting it
found
down.
set screws coming loose,
Mhm.
in a hub itself, or in a taper lock screws coming loose or whatever. You can watch that thing moving in and out slowly. It's like, well, there's probably part of our vibration issue. But
Mhm.
Yeah.
Yeah.
anyway, I think I've beat that one to death. So let's steer a different direction for a minute. So I know with you being with Ludeca now, by the way, represent, bud. I see.
Mhm.
Nice
Yeah.
hat.
I
Oh,
always
and
wear it every day.
I think are we all rocking the same coffee cup today?
Not me.
Oh, you got to get one of those. Oh,
Uh,
Brett's got
Just
his
the Yeti.
I&E coffee cup.
Hmm.
The nice cups. Do you have one of these yet, Colin? You're going to have to
Nope. I
shoot
need one.
Fritz
Is it
a.
Eric? Yeah,
It
Fritz.
is shoot Fritz a text and say send me a Yeti. But
I'm gonna
yeah, don't ask him. Tell him.
tell him.
Tell him
I don't
send
think
me.
that'll work.
Actually, call Laura. She'll do it for you.
No. Okay.
But no, so I know you're with Ludeca now. You've been with Ludeca about a year now, haven't you?
Yeah, getting real close to a year.
Because it was February that I first met you, and you'd been there a couple 3 months, hadn't you? At that point.
Well, my first day was December 1st of
Okay,
24. So,
okay.
yep.
So coming up on a year. So tell us a little bit about how you got to this point. Where you've worked in the past, how you got in to reliability to begin with. Just what your background
Yeah.
is.
It's actually a pretty cool story. I grew up on a farm, so I thought I was going to be a farmer, and it was a very large farm. But let's see, one, two, three, fourth generation. So there's a lot of cousins and cousins' families and all that. So basically, there's so many people that I finally realized this ain't going to work for making a living. So the only other thing I knew how to do that would benefit the world was welding. I could weld. So I thought, well, I'm going to go get a real job. So I went to welding school and got certified in MIG, TIG, and stick. And I got a job at an ethanol plant welding pipe. But when I started the job, I realized that I was the only mechanical maintenance guy on site. There's two electricians and me. My title was fabricator. But I was changing pump seals and changing bearings and things like that. I learned a lot, had no idea what I was doing, but I learned a lot. I actually burn up $2,000-$3,000 pump seals. That's how I learned how to set a mechanical seal properly. But then there was guys coming in all the time, balancing fans, collecting data, helping me change bearings. And I ended up talking to those guys and getting a job with them. And I spent 10 years with that company. I started in field service, and field service for that company was mostly balancing and laser alignment. They were doing it day in, day out. They kind of made a name for themselves just doing that. So I quickly learned to balance, and my route through vibration started with balancing. I learned to balance way before I ever learned vibration analysis. So I think it was a really good path to learn vibration because I already understood the units and I understood amplitude and phase and things like that. So vibration was easier for me to learn from that. So I spent some time in field service, started collecting data. It all started with the ski slope event that we talked about, but I got a little bit better at that. They upgraded me from a 2115 to a 2120, and I thought I was just the bee's knees with that thing. I got a 2120 now. with big old 8 meg card that slipped in the back of it. So then I got upgraded to a 2130, which I did not like. I got my Cat 2 or level 2. People debate on whether you should say level 2 or Cat 2. But I got my Cat 2 just so I could get into, I think it was Corteva, Pioneer. They call it
Yep.
Corteva now, but
They still have that requirement.
They required a Cat 2 just to collect. So I got to tell my boss, hey, I need a Cat 2 so I can help Don here collect data. So I got that. And when I wanted to pursue my Cat 3 later on down the road, they're like, well, if you do that, you're going to have to work with our vibration group. And I was like, ooh, that sounds fun. So I did that. And I spent 3 years just collecting route-based data, doing advanced balance jobs, advanced testing, which wasn't really a whole lot of advanced testing, but some IoTech, continuous monitoring kind of work we did. And then they asked me to come back to field service as the manager. I was really excited about that, but I quickly realized that I hated it. I didn't want any part of managing that group of technicians and doing service work for that many customers. It just became way too much to handle. So I wanted to go back to just doing vibration stuff, which I had a passion for, and that's what led me to Ludeca. When I realized I needed a change, the Ludeca job description was exactly what I was looking for. It was amazing how good of a fit that was for me. So I've had a blast doing what I'm doing now and meeting people and training and consulting and learning the products that we sell. It's been a blast.
Look at the bright side. You got to meet me.
Yeah. I met Adam Lunt real quick. Yeah.
I don't know if
was
that's
fun.
a good thing or not, but
Yeah. When I first met you, I thought, oh my gosh, this guy's gonna be a handful. But it didn't take me long to really strike up a friendship with you.
exactly.
It's still a handful, but yeah.
Those rough
Well,
edges, I was like, whoa.
I'm 100%. Well, and I remember, and I don't know why I this pops out, but I remember I met you over in Chicago. Um, we went over for some rep meetings, and that was back. Well, it was Super Bowl weekend.
Yeah.
They had the
Mm-hmm.
meetings on Saturday and Sunday, and we were over, I don't know, it was a Radisson or whatever. And when I got there, it was, middle of winter. I hadn't shaved in 3 months. I looked like a homeless guy when I showed up there. And you're probably thinking, what is going on with this
You
guy?"
were
And then,
holding a bottle of Jameson
yeah, yeah, I brought the
and,
Jameson Sunday morning.
and
Well, it
you
was
were
Super Bowl
venting.
Sun. Well, it was Super Bowl Sunday. And I remember I showed up in the little conference room and I brought a bottle of Jameson in and I set it down next to the coffee pot. And they're like, "What are you doing? We're in a work meeting." And I'm like, "I understand that, but it's Sunday." So, and it's
Yeah.
Super Bowl Sunday at that. So I'm going to at least enjoy myself if I'm stuck over here for the weekend. We're going to have a little
Mm-hmm.
Irish coffee. And then I looked over and one of the other guys from Ludeca is over there pouring himself one in the corner. And I'm like, "Yeah, I'm good to go. We're totally fine. Nobody's going to say anything."
Yeah.
But
That was a fun trip.
it's been great, and many more years of this to come too, because
Mm-hmm.
it's been great getting to work with you. Um, I've learned a ton from you. Obviously, we've been able to help. I mean, and hopefully more, but we've been able to help a handful of our mutual customers with both the cloud-based, continuous monitoring. People, and like I made the comment, that's the bad part about it is you now work 24/7 because
Mm-hmm.
you're monitoring 24/7. And how many times has it been 9 o'clock at night, 10 o'clock at night, you and I are on the phone together looking at a
Mm-hmm.
piece of equipment for a customer, just making sure that we're at least giving them the information. Now, could it potentially be a nuisance? Yeah,
Mm-hmm.
could be.
Turned out
But
it was on those
it
two
turns out that last
deployments.
one was a nuisance, but
We didn't
unless
know.
you got to take a look, and of course we're calling the customer at 9:30 at night. It's like, "Hey man, hate to bother you."
Mm-hmm.
"No, I'm glad you did," and then it turns out it was 100% a nuisance with production. But
Mm-hmm.
that's the beauty in it, just making sure that we can keep an eye. And then of course the answer is we need to now go out and physically put eyes on this piece of equipment. It's
Mm-hmm.
not unequivocally, because it turns out it's one of those things the sensor doesn't know. The sensor only knows what the sensor knows. But
And to bring that topic full circle, I would say wireless sensors are good for the machines that are hard to get to or the ones that need to be monitored more than once a month or whatever your program is. Start there. Let it
yeah,
help your program. Let it make the program better. You
no.
can put them on everything if you want, but I would start with the machines that are hard to get to and you want to monitor more often.
Yeah, high
That's what I
criticality.
would say.
That's usually a pretty good place to start with a lot of trial things. Let's find our high
Mhm.
criticality machines and see if this works on them. If it does, maybe we expand further. But
Mhm.
monitoring more often, that definitely has a plus too. Your trend data can become much more rich and usable when you're taken daily instead of just every 30 days.
Yeah. No one collects daily with a portable unit. That's just not going to happen.
It's just a lot of footwork.
Hmm.
Which, and I've always been a strong advocate for, and I know people do it, and that's fine, but I've always been a strong advocate for when you're first starting a new program, and whether this be ultrasonic lubrication, continuous monitoring, vibration, whatever the case is. And you're right, Brett, people like to start on their high criticality assets. I would urge them not to, because even though the program, these wireless systems, I mean, it's not, it's not snake oil, it works, but there's also a learning curve with anything. And do we really want to learn on a high critical asset?
Well,
Hmm.
agreed. But the only reason I say that is because it's like, Colin and I said too, if I've already got the portable data collector, then yeah, let's throw these sensors on there because the only
Yeah,
the only downfall is yeah, if it doesn't work, I'm still getting every 30 days. But now I could
that's fair.
possibly every single day I could get
Yeah.
fresh readings and say, you know what, there is something happening more than every 30 days. That's the only.
No,
But yeah, I agree.
that
Something you don't want to definitely try out with your critical
and,
machines.
and that is because, and that comes and like you said, full circle now, because now we're supplementing, not replacing.
Exactly.
And
Yeah.
and that's why it
Hmm.
works as a supplement. Because if we were going to say, for example, we are now going to stop doing route-based data collection. We're going to keep our portable for those, hey, we noticed something, we need to go out and, get some follow-up data on it. But we're going to stop doing route-based because either all the guys that knew how to do it retired or were budget cutting labor or whatever the case is. So we're going to replace with this online. Don't start on your high critical equipment.
Right.
Start
Hmm.
on something that's you got a redundant, if it goes down, it's not taking the plant down. It might be a nuisance, but at the end of the day, we can still create widgets or whatever we do. I just and like I talked about ultrasonic lubrication, let's not start an ultrasonic, because even though we can all agree ultrasonic lubrication works, it works very well, and it's the only proper way to grease. But while you're learning how to do it, let's not give a grease gun and some form of ultrasonic tool to a technician to go learn on something that's going to cost us 30 grand an hour when he jams too much grease in the non-drive of the bearing or non-drive in bearing
Because
of the
the
motor.
DBs are going up.
Yeah, he's like, oh, it's going up. We got to keep chasing. We keep chasing it. Then he ends up putting 14 tubes of grease in the motor windings. So
Hmm.
I don't know. I'm a little hesitant, but no, you are 1,000% right, Brett. When you're supplementing with online vibration, yeah, high criticality, that's a great place to start. And then
Hmm.
you also said hard to get to. I agree. And also safety ramification areas.
Hmm.
You know, we got to go up in a scissor lift with a harness and the whole 9 yards. I don't care what the criticality is. Let's throw a remote sensor on that one.
Hmm.
Now we just
Light
have to go up
curtains,
there.
cooling towers. There's a
Yep.
lot of
Now
good
we got to go
places
up there
for
every 2 to 5 years to change the battery. Other than that, it's kind of
it.
hands off. But anyway,
More
Brett,
frequent than that. The
do
only
you,
comment I was going to make was on the batteries. I almost brought that up earlier when we were talking about the wireless sensors. That is the one place I think, regardless of where you're buying your sensors, I think everybody's a little over optimistic on the battery life because I think what they're saying their quoted battery life is good for is if you were still taking every 30 days. But if you're going to get a wireless sensor, why the heck would I do every 30 days? I want once a day. And when you do once a day, that battery goes from 2 to 5 years to probably closer to a year. I ask about every class I have about this. I've been trying to just do my own research, and I'm seeing a ton of places where good luck getting one full year out of it, but they're doing frequent readings, which, if you're doing only every once a week or something, yeah, you could probably get a couple years. But a lot
There's
of what I'm
two.
doing is half a year.
That's a very good thing to bring up. There's two things that really impact that too. One would be the temperature. So the battery life is for ideal conditions. So temperature up or down will affect the battery life. And the other one is the length of the time waveform we get.
Yeah.
So out of the
And
box, these come with a very short time waveform. But if you have low RPM stuff and you increase the time waveform, which you can't do on every sensor, you're taking a much longer sample, and battery life goes way down from there. So it's very dependent on your parameters and the environment.
exactly.
Those both come into play.
And one of those due diligence things I always urge people when you're looking into an online system, one thing to look at is the availability of the batteries. And not only
Mm-hmm.
the availability, but is it proprietary? And what's the cost going to look like? Because a lot of times I've seen some of these companies out there, it's like, oh, yeah, battery life's great. But when you just bought 100 sensors and now in, say, 2 years' time, you got to replace all the batteries. Well, the batteries are $150 a piece, and I got to get
Yeah.
them from you. Ooh, that can start to add up versus I can go on Amazon or batterymart.com or whatever and buy a 20 pack of these off the shelf for, $50. Just something to one of
Mm-hmm.
Yeah.
those it's a consideration to make. I'm not saying it's the only consideration. There's a lot of things that go into it,
It's a
but
good point. Like everything we've been talking about, you really do kind of have to do your homework even before you do your research, which is kind of you're thinking, how much work do I need to do?
yeah.
But you need to know the right questions to ask before you even start to look to purchase these because there are so many different models where you buy the sensor, it's yours. That company no longer has anything to do with it. You use it, batteries die, you replace it. If it breaks, you're out. You got to go buy another one. You do all the analysis. Where there's also companies where you're leasing the thing, you don't touch it. It's theirs. They just put
Mm.
it in your facility. They take the readings. They analyze it for you. They replace the batteries. When it falls off, they'll send somebody out to replace it. There's so many different models of how you can do this, and you do need to be careful and at least be aware of what they are so that you know the right questions to ask when you start shopping. What kind
And
of battery
find
life? How many sensors am I going to use? Because they're based on bandwidth. A lot of them will use like cell signals. So 4G, 5G networks, the more of these you put on there, it's just like bandwidth back in the day. You only have so much if everybody's on it. You have 100 sensors instead of 10. You start running out of bandwidth, and you have to pay more for that too. So you got to start doing your homework even before you start really doing shopping for it, to be honest.
Mm-hmm.
And the nice thing is, if anybody out there is in the market or looking, this is something we can definitely help with because I don't believe there is a cookie cutter one size fits all. It depends on, how much experience do you as a plant have with vibration? How much help do you want? How hands on do you want to be? How hands off do you want to be? So with this is something we can help with, kind of tailoring, and I'm not saying sell it to you, but kind of tailor it to here's how this one will fit your project. Here's how this one would fit your project. And then you guys can make an educated decision. Myself, Brett, Colin, we're all happy to help with that. You can reach out to anyone. You can, obviously get Brett and I on the at reliabilityu.com. We're always there. Colin, shameless plug for you, ludeca.com has, they've got that information as well. And they've got a bunch
Mm-hmm.
of extremely talented people, not taking anything away from you, but it's not just Colin down there. Colin's not a one
Mm-hmm.
man show. They've
No,
got a
I'm very
good team.
fortunate to have this team to back me up.
They've got a great team of guys down at Ludeca. A great, network across the United States to help people with that as well. Brett likewise can help out with this stuff, and so can I. So reach out if you need help with any of this stuff or have any follow-up questions or want further discussion on any of these topics. We're always, here to help because like I said in previous episodes, and I'll say it again, a sharp knife doesn't make you a surgeon, and you can buy all the stuff you want, but if you don't have the training to know how to use it, you just bought a bunch of lead paperweights. So
Mm-hmm.
let's make sure you're getting the most out of your tools. But Brett,
Yep. Exactly.
we've been going for quite a while. I think we got a lot of good information shared. Brett, do you have any follow up before we call this a day?
No, because we could keep this thing going probably 2 or 3 hours with us three, I bet, and still be talking entertaining ourselves, but we got to
I
think
have
about
more stories.
Yeah, I know. We just have to have you back on another topic.
Yeah, that'd be fun.
But yeah, we appreciate you coming on though, and it's nice to meet you. Since we haven't met
Mhm.
yet, it sounds like we have quite a bit in common, and I
Yeah,
picked some stuff up from you I know today that was very interesting and good
and I
information.
learned from both of you too.
Awesome. Well,
This was
Well, it's the best
beneficial.
part of it. So Brett's son's name is also Colin. So you
Oh,
can now say that you got to hang out with a cooler Colin today. Make sure you tell your kid that.
oh yeah,
is it 2 L's or 1 L?
it is 2 L's. Yeah,
Yes, that's the
I
only way to spell it.
it is.
Yes,
Yeah.
that's the only way.
All right. Well, Colin, man,
Yeah.
I appreciate the time today. Appreciate you taking the time out of
Yep.
your day to hop on here and talk with us and hopefully educate some people, get some good stuff out there in the interwebs so we can all learn together.
Yeah, thanks for having me on. It was a blast.
All right, man. Well, you guys have a wonderful day.
All right, see y'all.
Yes.
See ya.